everyone, today's topic is about the types of precipitation and their formation principles. I believe all of you are familiar with the science project of beauty chemistry. Beautiful chemistry captures the colorful colors and subtle details of chemical reactions with a high-definition camera, presenting us with the unique beauty of chemistry, many of which are precipitation reactions. For example, copper sulfate is mixed with sodium hydroxide to form a copper hydroxide precipitate that looks like a blue swimming pool. The green emulsion of nickel hydroxide precipitate forms when nickel sulfate is added into sodium hydroxide solution. And silver nitrate reacts with sodium chloride solution to form a white pyrotechnic silver chloride precipitate. From these pictures, we can see that the color and shape of precipitates vary. Then, how do the precipitates form? Why there are different types of precipitate? In general, precipitate can be roughly divided into two categories according to the size of particles. One type is crystal precipitate. Another type is amorphous precipitate or colloidal precipitate. The particle diameter of crystal precipitate is about 0.1 to 1 micrometer, and the crystalline ions are regularly and closely arranged in the structure, such as barium sulfate and magnesium ammonium phosphate, etc. The diameter of amorphous precipitate particle is less than 0.02 micrometer, and the precipitate particles have no regular accumulation. The precipitate particles are loose, watery, and bulky, such as aluminum oxide and water. Between crystal precipitate and amorphous precipitate, there's cloudy precipitate, whose particle size is also between these two particles, such as silver chloride. The type of precipitation is determined by the physiochemical properties of the precipitate, but the precipitation conditions also play a significant role. For example, the size of the precipitate particles is related to the concentration of the crystalline ions during the precipitation reaction. The formation of precipitate is a very complex process, and there's no mature theory at present. It is generally believed that crystal nucleus is firstly formed in a supersaturated solution and further grows into precipitate. Precipitate can be amorphous precipitate or crystal precipitate according to the different orientation speed and aggregation speed. Then, there are two key steps in the process of precipitation formation. One is the formation of crystal nucleus, and the other is the growth of the crystal nucleus. There are homogeneous nucleation and heterogeneous nucleation. Let's first discuss the homogeneous nucleation. It is a process that the crystalline ions associate to form crystal nucleus, such as barium sulfate precipitate. Barium ion is associated with sulfate to form ion pairs. The ion pairs can further combine more cations and anions to form the nucleus. A barium sulfate crystal nucleus is constructed by 8 ions, namely 4 ion pairs. The basic condition for nucleation is that the solution is supersaturated, which means that the concentration of the solute Q is greater than the solubility of the precipitate S when the nucleus is formed. In the case of heterogeneous nucleation, there are other fine particles in the solution, such as dust, impurities, and other particles. In the process of precipitation, they play the role of crystal nucleus and induce the formation of precipitate. The first process of precipitation is the formation of crystal nucleus, and then the crystal ions in solution will continue to migrate and deposit onto the surface of the crystal nucleus, leading to the growth of crystal nucleus. To a certain growth degree, the precipitate particles will form. Precipitate particles can aggregate into larger ones, which is called aggregation. At the same time, precipitate particles tend to form larger crystals in certain lattice arrangement, which is called orientation process. The aggregation rate is mainly affected by the relative supersaturation of the solution. The higher the relative supersaturation, the higher the aggregation speed is. And the orientation speed is mainly related to the polarity of the materials. Salts with stronger polarity generally have a larger orientation velocity. The type of precipitate depends on the relative speed of these two processes. If the aggregation speed is slow and the orientation speed is fast, then the crystal precipitate is obtained, such as barium sulfate. On the contrary, if the aggregation speed is faster than the orientation speed, and the ions cannot arrange orderly on the surface of the crystalline nucleus, it is easy to form amorphous precipitate, such as copper hydroxide precipitate. This lecture mainly explains the types and forming principles of precipitation. At the end of course, please think about what are the types of precipitate? What are the two key steps of precipitate formation? The KSP of barium sulfate is similar from that of silver chloride. But why are the obtained precipitate types different under the same conditions? That's all for today. Thank you for your attention. See you next lecture.